This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Sam Taggart. I am here today with M. Scott Ford. Scott is the co-founder and CTO of Corgibytes. He regularly conducts training courses on O'Reilly's Learning Platform and LinkedIn Learning. Scott is the host of the podcast Legacy Code Rocks and manages their Slack group, which I'm a part of. That is how I met Scott. Scott is here to talk to us today about a tool he has built to manage dependency freshness. So first of all, Scott, let's talk about defining dependencies. What do you mean by the word dependencies?
Yeah, so I think in general, it's best to think of it as code that you didn't write that you're pulling into your application from somewhere else.
So how are you typically pulling that code in? Is it through a package manager, both?
It's varied kind of across history of programming. So I think in the days of yore, it would have been like, copy and pasting from another source or copying a file into your project directly or buying a third-party product that had to be installed into your system with an installer. So there were like DLLs that were installed that way. And then also in some ecosystems, those pieces of code that you're consuming from elsewhere are either part of the operating system or can be installed with an operating system package manager. But for most modern programming language environments, there is some kind of dependency manifest file that allows you to specify the packages and libraries that you're depending on and optionally what versions of each of those libraries you want to consume.
Cool. So you mentioned versioning plays a very important role in managing freshness. So can you kind of talk a little bit about that?
Yeah, so freshness, there are multiple ways to define it. First, let me take a step back and say that the term dependency freshness was introduced in a paper by Joel Cox et al. I forget the name of the paper, but the idea is that how out of date the version you're using is. And there's different ways to measure how it's out of date. So you can look at the version number and you can kind of compare components of the version number that you're using to components of a later version number and get a distance between the version you're using and another version, whether it's the latest version or the latest for the series that you're targeting or whatnot. The metric that I like the most is one that's called lib year, and it's also referred to in the paper as like a time-based kind of temporal distance. So it's looking at the release date of the version of the package you're on and comparing that with the release date of the latest version, and you get a distance in years. And so if it's been 6 months between the version that you're using and the release date of the latest version, then the lib year for that package would be 0.5, because half a year being 6 months.
Now, I kind of see that giving some problems because certain projects have more churn and are releasing more often than others.
Absolutely.
There's probably some projects that are stable and only get revved like once a year or something when they find a bug, versus projects that maybe are in development or are constantly churning out new versions. Is there a way to account for that, or this method just doesn't take that into account?
Yeah, unfortunately, this method doesn't take that into account. There are, some of the other freshness measures, if you key them to, like, you want to stay on the major version that you're on, but you want to make sure that you are always on the latest minor version, right? You can look at distance measures that will help you compute that. But lib year, just on its surface, is always comparing against the latest. So that is a little bit of a weakness in that. Another weakness is that freshness doesn't really communicate quality of the dependency itself. So, there are other factors to consider as well, such as, is the package that you're using, is it still being updated by, community support or a vendor, or has it been abandoned? So, you might be on the latest version, so your dependency freshness score would look really good because you're on the latest version, but that version isn't in itself like 8 years old or something like that. And that's not necessarily a bad thing. Like you said, like it could be really stable. It could be just an easy to understand problem. The things that it depends on don't change often. So it doesn't have a need to change. Or it could be that, there's just not any more work on it, and it's not receiving bug fixes, it's not receiving security updates, it's not getting operating system updates to support newer environments or newer processor architectures. Those are also possibilities. So I think sometimes these things warrant investigation, and I think there are different trends that you can start to look for and you can start to spot. So if you've got a dependency that you're on the latest version, but that version's more than 5 years old, then maybe it's worth investigating, or 4 years old or 3 years old, whatever your threshold might be. Maybe it warrants investigating, has the community abandoned that package? And is it time to look for an alternative? So I think there are kind of signals that will start to show up in the data that you can look for, and then start to use those as targets for further investigation.
So I think this brings us to a very important question, which is, why is dependency freshness important? Right? What possible things have you seen go wrong when dependencies are old and out of date?
Yeah, so to me, it shows up in 3 different ways. There's kind of 3 factors, and depending on your organization, each of these factors will have a varying degree of importance. One is staff turnover. So most teams that I've worked on, the developers on that team get frustrated when they have to work with libraries that are consistently out of date. It becomes a productivity challenge as well. So, but that's the second factor. So, sorry, keeping with that first factor. So, as people get more and more frustrated, they will eventually not want to work on the project anymore and then look for a job elsewhere. So, that is a factor, and it is a very real factor for some teams, especially when there are lots of opportunities for software developers to seek other forms of employment at other organizations. That can be a really big challenge for teams is managing turnover. And so I think, it does create a little bit of turnover risk.
And probably recruiting on that part too, right? So
yes,
some people want to leave and new people come in, and if they're interviewing and you say we're using 10-year-old technology, that probably gets,
Yeah. And I've heard it joked that a lot of developers perform resume-driven development, where they like to pick the tools that are going to make their resume look good for the next gig. And if the work that they're doing right now isn't going to help them further their career and make it easier for them to get the next opportunity, then they feel like they're starting to take on some career risk as well. So I think that is a really real problem. I think it's really hard to quantify. I think it's hard to notice when you're getting into that situation. It is real. Now, the frustration that those individuals are experiencing is often in the form of it being harder to work with an older dependency because of the information that is out there about the projects. So typically my experience has been, and I can definitely speak from personal experience on this, when I'm working on an older version of a library, or working with an older version of a library, and I'm trying to investigate how to do something with it. So there's a problem that I'm trying to solve, or I've encountered an issue that I'm trying to work around, or I'm trying to solve a problem in a new way, and I'm doing a lot of research. What I often find is that the resources that I'm directed to are for newer versions than the version that I'm using. Because what often happens in libraries and packages is, as challenges are encountered by members of the community, the people maintaining these packages start to solve some of those common problems in subsequent versions. So you can often find yourself in a situation where the problem that you're having has been solved by the community, but it's been done so in a version that's newer than the one that you're on. And if there are impediments to you being able to upgrade, then that becomes really challenging.
So my reaction to that was actually a different reaction, in that I've had the opposite problem using Linux a lot, because for newer versions of Linux, some of the problems that you encounter, because it's newer, not as many people have run into that problem. And so I Google, how do I do XYZ in Linux? And all the documentation is for some older version of Linux where they've now updated all the tools and it works differently. So that's just an interesting data point.
Yeah. And then the third component for why freshness is important is security. And then for a lot of organizations, this is the one that's most important. And that's that security vulnerabilities don't get fixed in the exact version that you're using, right? Like you're targeting a specific version of a third-party project. And so by incorporating that into your code base, if there's a vulnerability in that third-party dependency, there's now a vulnerability or potential for vulnerability in your code base. Now, you might not be exercising the library in a way that would expose your project to the vulnerability, but the risk is certainly higher than it would be otherwise if there wasn't a vulnerability in the third-party dependency. So you will need to be able to upgrade to a version of the library that doesn't have that vulnerability. So looking at freshness and starting to consider, a measure of freshness being how many known vulnerabilities are there in a package, right? So like the idea being that if your library is supported by a community that's very active and stays on top of security vulnerabilities and patches them relatively quickly, then the latest version should not have any known vulnerabilities, right? There should be at least a version of that project with no known vulnerabilities. And you can target that version. And so the number of vulnerabilities and the levels and severity of those vulnerabilities can start to be used to kind of form an additional freshness metric kind of separate from the version number itself.
Yes, that's interesting. So you're not only relying on the new version, but you're also relying on the maintainers. So that in a way, when there's a bug, the maintainers actually have to go and issue a new update, right? So if the bug is found and nobody fixes it, that also doesn't bode well.
Yeah, and so if there's not community support for that, you've adopted this dependency into your project, and so when you become aware of the fact that there's a vulnerability, you now have a responsibility to make sure that gets fixed. And it could be really understanding the vulnerability and making sure there aren't any code paths in your application that bring it to life, so to speak, or it could be finding a way for you to fix it or patch that library yourself by forking it and creating your own version.
That speaks to the value of having open source dependencies.
Yes. Yeah, because that becomes possible, right? Whereas with a closed source third-party dependency, it's much less possible. It's not impossible. It's much less possible
Yeah.
to get in and fix things yourself.
Yeah, in that case, the best you can do is try to prevent that code path from being executed or do some kind of mitigation. So how do developers currently manage this freshness and keeping stuff up to date without talking about your product yet, Freshly? Like, if people aren't using that, how do they handle this problem?
Yeah, so there are a variety of approaches, and there is starting to be better and better tooling kind of introduced to help teams stay on top of the challenge and stay on top of the problem. Most package managers have a command that you can run that is like usually outdated or something along those lines. So there's like npm space outdated. There's bundle outdated. I think there is at least, or if not, there's a plugin for it. So there are different package management communities. There's like NuGet outdated as well. There are different package management communities where you can kind of get a list of the versions that you're depending on and what are the latest versions that are available. And they'll usually present it in a variety of ways. So it'll show you the way that the version has been specified in your application. And you can specify versions usually in a multiple number of ways. You can specify an exact version number, or you can specify an expression that will resolve to an exact version number. And most of these tools that let you know whether or not there's a newer package, they'll let you know first if there's a newer version that satisfies that expression that you've defined for the version number. And it will also show you if there's a version that's even newer than that to kind of help you kind of assess which might be easier to upgrade to.
So I have a question for you. You work with a lot of legacy code bases. Do you generally prefer to specify exact version numbers or minimum version number? And what are the trade-offs there?
Yeah, so I like there to be some mechanism that specifies the exact version number. Like usually that's in the form of a lock file. So in the Yarn and NPM ecosystems, it's either packages.lock or yarn.lock. In the Ruby ecosystem, it's gemfile.lock. I'm not sure what it is in the .NET ecosystem, but I know there is one. There is a lock file that does pin down the exact version number. And those are like, that is, I think it's important for applications at least to be able to specify the exact version number that you expect to install, especially like when comparing a local development environment with a production environment. You want to be able to have those two environments relatively in sync with the version numbers that are getting installed. Otherwise, you can run into potential problems with production have an older version of a package, and the bug you're trying to fix has actually been fixed in a dependency, but you're not able to observe that bug because you've got a newer version of that dependency locally. So it is important to have some kind of mechanism for keeping those in sync. And if the package manager that you're using doesn't provide that mechanism, then I think you do have to specify exact version numbers.
Yeah, that's kind of like the works on my machine problem.
Exactly. Yeah. So when you do have ranges available to you, so if you're able to kind of partner ranges with exact versions, then I think it makes sense to look at the way version numbers are being specified for the dependency that you're using and specify the version range in such a way that you're able to absorb any new versions that don't have any breaking changes. That's kind of a promise that the package maintainers are making to you, is that certain version number increments won't have breaking changes included. There's the SEMVer or semantic versioning convention that specifies which parts of a version number are allowed to change based on what changes have been introduced as part of that version. So if there's a breaking change, the first digit in the version number is supposed to increment, as an example. So if the project that you're consuming complies with SEMVer, then you can say that like the major version that you're on, you want to keep that the same, but then all newer versions are acceptable. And then you might specify like a minimum version within that category. So it could be that you started a feature that your application needs was introduced in, say, 3.5. And so anything less than 4.0 is okay, but it needs to be greater than 3.5.
Okay. So how common do you think it is for companies and projects to have out-of-date dependencies? Is it widespread?
Crazy common. Crazy common. Yeah, there's a report, the OSSRA report from 2023. So nearly half of commercial code bases contain a known high-risk vulnerability that has been patched. And it's 48% of those code bases. So that's a data point where we can point to and say, like, these are known vulnerabilities that are present, and there's a fix for these vulnerabilities, right? So that means those packages have to be out of date, right? Like, it doesn't happen any other way. I don't know of like specific data for like how many companies have what percentage of their code base is out of date or whatnot. But I think like that number tells us a lot in and of itself.
Yeah, and if people want to know about the consequence of that, they could probably just go Google Equifax, because
Yes.
that is the shining example that everybody knows about.
That example is what really got me really interested in this area and kind of dependency freshness in general. And it was specifically when I read an article that was published by Ars Technica, where they reported that it was Apache struts. So it was a vulnerability in the Apache struts library, so the Apache struts web framework that was being used by Equifax. The vulnerability was published, and at the same time that the vulnerability was published, the fix was released. And it was 2 months after that publication that Equifax was hacked. And the vulnerability that was exploited was one that was fixed prior to that 2-month window. So the development team had 2 months to patch it. Now, I've worked on plenty of development teams where upgrading a major dependency, such as like Apache struts, like something that's absolutely, for a web project, that's absolutely foundational and presents a high level of risk for upgrading. But to me, their inability to do that within 2 months, to me, communicates a pattern of practice within the development team where it had become hard to do upgrades and it wasn't routine. And so I think teams need to get to the point where doing upgrades of these sort becomes routine. And so you were asking about tools earlier. Dependabot is another great tool for this. There are other tools that have similar capabilities, but it will notice that there's a newer version of a package that you're depending on, and it will open up a pull request for you that patches that package, and you can look and see if your test suite passes. And so if you've got a strong enough safety net to help you notice when upgrading a package is going to break something. Then you can start to build some trust that upgrading isn't going to break anything. That needs to be said with a giant caveat, however, because there have been some sophisticated vulnerabilities that have been inserted exploiting that practice. And these are known as supply chain attacks, where a bad actor has gotten access to the source code repository of a popular library, and they've inserted malicious code and released a new version. So, pretty much the only change in that version is the inclusion of this malicious code.
So there is a previous episode of Software Engineering Radio that covers that, and I do not have the number off the top of my head, but we can throw it in the show notes. So you started to answer my next question. My next question is going to be, why do organizations struggle with out-of-date dependencies? I think you hit on one reason is that it's hard to upgrade, and people are afraid of breaking their code when they upgrade, and they don't have the test infrastructure around that. But what other reasons? Is it from an organizational standpoint, is it lack of info or visibility? Is it incentives? Is it sometimes they just don't care or don't know?
I think it's sometimes all of those things, or all of them at once, or any number of them. I think that awareness is a big part of the problem. When projects get created from scratch, they're almost always using the latest versions of things, and then they just continue to work, right? Like those versions that you're depending on, they're just continuing to work. And very much within the vein of it's not broken, don't fix it, there's not really a big need or a big motivator to keep things up to date. And so it can be easy to kind of not maintain that awareness as a result. I also think that on teams where there is awareness that there are problems and that those problems are caused by things being out of date, there's often a situation where leadership doesn't see the value in investing and making a change that doesn't provide any new functionality. So upgrading a third-party dependency, if done correctly, it's not a user visible change. Or if there is a user visible change, it's because things are faster, hopefully not things are slower, but usually there's a performance impact, or maybe there's a bug that gets fixed, but you're not going to get a new feature as a result. You're not going to upgrade a third party. It's going to be pretty rare that you upgrade a third party dependency and now you have new capabilities that you're able to offer your customers just by upgrading the dependency. That newer version might allow you to then build upon the features in that newer version to provide value to your customers. But there are a lot of business leaders that you don't see the value in that investment. And then the issue that I mentioned before, in that a lot of teams kind of view it as a risk, in that a lot of these dependencies many of them are foundational, or they're only used in a very small part of the code. And both have problems. So the ones that are foundational, you have the risk that it'll break everything. And that's often what people are afraid of. But there's also the risk that it's going to break something in a very nuanced, minor way. Because just because the team that's put out the newer version, just because they're shipping bug fixes, they're shipping performance enhancements, they're shipping security vulnerability remediations, it's still possible that they've introduced new bugs. There's no way for us to solve the halting problem. So introducing change into your system is introducing risk. And so, that ends up becoming a risk that you need to manage. And there are a lot of teams that are pretty risk averse when it comes to things breaking. And I think that's largely because they don't have very thorough tests around whether or not their dependencies are doing what they expect them to do.
So that brings me to a question when it comes to dependencies and testing. Do you typically recommend that you write tests around the libraries that you depend on, or do you just test those as part of your tests for the rest of your code? Some path is calling that dependency and therefore it gets tested.
Yeah, so for the approach that's best taken kind of depends on the kind of dependency that you're working with. I think for a foundational dependency, such as a web framework, that is best tested just as part of having end-to-end acceptance tests. So tests that exercise the full stack, because that's going to be exercising that dependency. And the work that dependency is providing you will get exercised as part of that. If it's a dependency that's providing you one specific capability, maybe it takes a Word document and generates a PDF or something of that sort, right? It has a very small nuanced task, I think in those cases, it makes sense to have like a small integration test that exercises that dependency and makes sure that it continues to work the way you expect it to. You don't need to exhaustively test it. Like the team that's releasing it is going to be testing it, but test what you need out of it, right? Like test that it's providing you what you need out of it. And again, those don't need to be extensive, but really trying to think about like, okay, if there was a breaking change that was introduced, I would want this test to fail. If you're using a dynamic language where the compiler isn't able to notify you about breaking changes like that, then you would want your test to fail if breaking changes like that was introduced. Or looking at the output of what gets generated and making sure that it's equivalent to what you expect it to be. And if it's not, then that means a bug was introduced as part of that dependency. And you probably only need like maybe one or two of those for those kind of minor dependencies. But for the more foundational dependencies, it's next to impossible to really exercise everything you're utilizing from it, because often the design of those foundational dependencies really influence the design of your application. And testing your application in isolation of those dependencies really requires a completely different architecture for your application than is commonly used. So if you've adopted such an architecture, like a hexagonal architecture, then you can leverage some of the test points that are available within that. But if you haven't, if you've just kind of like, you just quickly built on top of it, then there's not a lot of utility in testing those dependencies independently.
Okay, so let's move on and talk about just Freshly itself. Can you give me a brief summary? Like, what is Freshly? How does it relate to all this stuff we've been talking about?
Yeah, so and it's gone through a few iterations, and it's definitely something that continuing to work on and continuing to reimagine and evolve into something better based on feedback from people I'm sharing it with. But it really started out as a experiment for graphing how dependency freshness metrics changed over time. So taking the data out of a dependency manifest file, computing dependency freshness metrics for the dependencies that are specified in there, but not leaving it at that. There are a lot of tools that compute libyear. There's probably, if you go to libyear.com, there's a good list of tools, and there's probably one for the language that you're using. It'll read your dependency manifest file and it'll spit out the libyear value for all of your packages. What I was really interested in is how those values change over time and what they might be communicating about the team's behavior and about how things are trending for them, what they might communicate about the community of dependencies that are being relied on. So what Freshly does is it looks at the history within Git, and for as much history as it can get access to, it computes the libyear metric across that time. By default, it does this in 1 month intervals, and it computes the metric as it would have been at that point in time. So if it's looking at like, January 1st, 3 years ago, then what would the dependency freshness, libyear metric look like at that point in time? And so then able to graph that for teams and then show how these values have trended over time. I also wanted Freshly to be supportive of ecosystems and project structures where there were multiple dependency manifest files that are present. And I wanted it to be a tool that supported multiple language communities.
So which languages do you support?
Yeah, so in the first initial version we had, which you can play with by going to freshly.io, that's kind of the initial alpha, that has support for PHP via Composer, Ruby via Bundler, Python via requirements.txt file, .NET via looking at CSproj files, and I think that was it. And then maybe Perl using a CPAN file. The initial approach that was taken there was to write code in the host language, the language that Freshly was being built with, which we ended up, we picked C#, but write code to parse the dependency manifest file formats in these other ecosystems. And that worked pretty well for, those initial targets, Ruby, PHP, Python, that worked pretty well. And then we were writing inside of the .NET ecosystem. So tooling was readily available for, APIs were available for us to do this work in .NET. One thing we did start to notice is that we felt like we were duplicating effort. We knew that there were libraries in these host ecosystems that already knew how to parse these files and already knew how to do the dependency resolution for an expression and things like that. And so, but we were having to like re-implement all that logic, and there was risk that we would get it wrong. And we did have a lot of initial bugs at first where we did get some of those things wrong. So that had us kind of wishing that we could, kind of leverage code that already existed in those ecosystems. And then when we went to go add support for the JavaScript ecosystem, specifically Yarn, Yarn's lock file format is non-trivial to parse. And then also when we started looking at the Java ecosystem, specifically with Maven, the pom.xml file and the various ways that versions can be specified and the various ways that pom.xml files can refer to other pom.xml files, that just seemed like way too big for us to re-implement. And so we ended up pivoting to an approach where we have a core CLI application that knows how to do things like compute libyear based on a common file format. But then we have language agent programs that are written in the host ecosystem and are able to leverage APIs in that host ecosystem. And then the CLI communicates with those. So we've got, under that approach, the newer version of the CLI is done for the most part. There's obviously still things that we'd like to add. And then we've got a language agent built for Java, and we've got a language agent built for .NET. And we have ones in progress for Go and Python.
So the language agents then are like a plugin type system?
It is very much like a plugin-like system. It's a plugin that is an executable. So in that executable, when you start it, runs a gRPC service that the CLI is communicating with, that the central CLI is communicating with. So then the CLI is responsible for like walking through the history of the Git repository and figuring out like what points in time need to be analyzed and what Git SHAs need to be looked at. It's responsible for doing that. And then it asks the language agents to detect any dependency manifests in a particular file tree. And then it asks it to create a software bill of materials. We're using the CycloneDX SBOM format for that.
Engineering workflows can be a mess. From prioritizing sprint tasks to explaining technical diagrams, you're spending more time explaining work and less time doing it. Miro brings all your work together seamlessly in one online visual workspace. Create diagrams in UML or Mermaid, run sprints, and create Jira or Azure tasks in Miro instantly. Go from idea to action without switching to different tools. Get your first 3 boards free when you sign up today at miro.com/podcast. That's miro.com/podcast.
Let's continue just talking about the plugins and the different ecosystems.
Yeah. And then the central CLI is also responsible for communicating with the API that the data gets transmitted to, so you can then view the graphs on the website. That's how that architecture is set up. So the language agent plugins are really only responsible for looking at detecting dependency manifest files in a directory tree and then converting those into an SBOM format so that the CLI can then work with it. So what the CLI does is it uses the SBOM file to compute the libyear metric.
So while we're talking about SBOMs, I want to talk about later, but let's just talk about it now. You had talked about security earlier, and I think this kind of ties into that. So what is an SBOM?
Yeah, so it's a software bill of materials, and it is a structured document that specifies all of the third-party dependencies that an application is using. It can specify things other than that. You can craft an SBOM to also communicate to the third-party like web-enabled services that you're communicating with. And then SBOMs can also can communicate other forms of metadata as well, such as like the license that's being used. So they're a pretty good file format for different kinds of analyses, especially the CycloneDX file format, because the CycloneDX file format has the ability to also include information about vulnerabilities that are known for the packages. So from a single file format, you can do analysis for what licenses are being used across your project. So you can kind of you can do some due diligence around, do you have exposure for license violations? Like, are you consuming code that has a copyleft license that you may or may not be complying with? Or maybe your organization has a policy that like a particular license just isn't allowed. That file format and the tools that can generate for you can help you do that analysis. It also includes in it a tree of the dependencies that you're using. And the tools that generate these can be usually configured as to whether or not they include dependencies that are used for development versus dependencies that are used for production. So, depending on what you're interested in, you can adjust them that way. And so you can kind of see the version numbers that you're using. Also, there's usually a hash of those versions. So you get some kind of like cryptographic check of what that code should look like. So then you can kind of do tests against different deployment environments to see if your dependencies have been modified. So that's another thing that it can be used for, is to kind of make sure that the correctness of those files is still good, that those dependencies haven't been modified by a bad actor.
Okay, so the SBOM then lists all the dependencies in a tree. It lists the version. It has a hash. It has potentially vulnerabilities.
Yeah, potentially vulnerabilities. It has license information. It'll likely have author information, links to documentation. There's a lot of metadata that can be embedded in there, and it really kind of depends on the tool vendor that you're using and how much data they provide, and also how much data they're able to get from the projects that publish these packages.
Okay, and the reason SBOMs are in the news is because there's talk, at least of the government requiring them for certain things, right? Or maybe they already are required for.
Yes. So there was an executive order signed a couple years ago by the Biden administration that mandates that they're created in different scenarios. I don't know all of those scenarios, nor do I know. I'm not super aware of like what the requirements for what an SBOM needs to have in it in order to comply with that. But it is a file format that teams are starting to be aware of. And one thing that I think is really nice about it is that prior to these SBOM based tools being introduced, you had lots of different language ecosystems with fragmented ways of defining these dependency trees and the SBOM file formats. And there's two pretty prominent competing standards, the SPDX and the CycloneDX. Or is it SPDX? The one that I'm not used to working with. CycloneDX is the one that I'm more familiar with. That's the one that we're using under the covers in Freshly. And so now you don't have like this huge fragmentation across language boundaries that you had before.
Okay, so if I needed to generate an SBOM for my project, I could potentially use Freshly to do that.
Yes, and that's something that we're going to make more visible. Right now, the SBOMs, they're getting created in a folder in a .freshly directory. And again, because we're going back in time, we're computing the SBOM as it might have looked. We're not 100% exactly sure that it's correct, but as correct as we can make it for what the SBOM would have been at that point in the past.
Okay. So what does that look like? Like, how do I use Freshly? Is it a service that I connect up to my GitHub account? Is it a program that runs locally on my computer? How does that work?
Our initial envisioning of it was that it would be kind of a software as a service thing that you would connect your GitHub account to and then do the analysis. We got some feedback from some different organizations that were nervous about a third-party service having access to their source code. And we didn't want to be a target for getting hacked. So as a way to kind of minimize both the risk to the code base owners and kind of minimize the risk to ourselves, we kind of pivoted away from that approach. And so now the CLI is what does the collecting of the data. It's what does the analysis. And then the metrics that it's computed and the SBOMs are getting sent up to the Freshly API. And then you'll be able to log into the Freshly website and then see the analytics and graphs and recommendations based on that.
Okay, so what type of reports and graphs can I see in Freshly? And then the following question is, what kind of insights can I get from that? Because you mentioned earlier that instead of looking at one point in time, you look over time. So what does that time frame tell you? Maybe you can give some examples of like things that you've noticed and then what the solution was or what problem it pointed out.
Yeah, I can certainly give some examples. So the graphs that we're currently producing are based on lib year, and we're looking at a project's total lib year. So we take the lib year value for each package and we add them all together to get a composite, aggregate value for your whole project or for the whole dependency manifest file, and graph how that's changed over time. Now, there are multiple reasons that number could go up. Like it's highly sensitive to the number of dependencies, right? So the more dependencies you have, the chances that number is higher is going to go up. So it's going to scale. It's going to likely scale relative to how many dependencies you have.
So question though, can I look at that then as a way of like measuring my exposure in a way? Because if I have one really old dependency, I have a lot of exposures. But if I have a whole bunch of different dependencies, even if they're all relatively up to date, that's also more exposure. Am I thinking about that right?
Yeah, I think so I've been thinking about that like total lib year as a stand-in for risk. I wish I knew how to convert that risk into dollars, like how much money is on the line, like how much financial risk there is. But I do think it is a measure of some kind of risk. I'm not sure what yet. But as that number goes up, your risk has also gone up. And there's multiple ways that it can go up. Like you said, like it can go up a little bit across a lot of packages, or it can go up a lot in one package, right? But the level of risk that you're carrying in your project has increased. So we look at the total, and then for applications, the metric on the Libyear website, they say on their website that they try to keep application totals to under 10 years. So, for a particular application, under 10 years, in their opinion, is pretty good. And so you can imagine, like, if you've got like 100 dependencies, right? You can hit that 10-year figure by having like an average of 0.1.
Yeah, that was going to be another question that I had was like, what's a good number? If I'm looking at the number, like, so that's a question, right? Are you more interested in the number itself or the trend over time?
I'm more interested in the trend. I think that the trends and what they can tell us is more interesting than the numbers. And so the other graphs that we look at average, and average pretty much has the exact same shape. Like if you were to squint, you wouldn't really be able to tell the difference between the total graph and the average graph. But the scale is different. So you can kind of, you can get a sense of what the scale might be. And then we also graph the maximum value. And I think that's pretty interesting. And that's one that I think having some hard thresholds on would be a good idea for teams. And that's something that we plan on adding support for, is being able to integrate freshly into a CI/CD pipeline and failing a build if the maximum value has crossed a particular threshold. So like, has the maximum value crossed a year? So is there at least one library that's more than a year old in your code base? And that could be like just a hard threshold that your team sets.
Yeah, and I imagine if you had one that was stable that you didn't care about, you could potentially keep that out of the running, or say if there's one one that we care about, you can ignore it or something.
Yeah, you could create an allow list or like libraries that you ignore, things of that sort. But like having some kind of way to like, plug into the CI/CD pipeline and say that like, these are the thresholds that we care about, like whether it's a threshold on the total, a threshold on the average, or a threshold on the maximum. And then the final graph that we put together, it shows all of the packages over time. So every single package your project has ever depended on and what the libyear values have been over time for those. And that's the graph that I think has shown some interesting insights. And I'll talk about those, and I'll talk about some insights that can be gained from some of the others. I've given talks at a couple different Python conferences and have shown graphs from different open source applications in the Python ecosystem. What's interesting for a lot of them is the trajectory that libyear goes up before Python version 2.7 was declared dead. It's a very different trajectory than after Python 2.7 was declared dead. And so you can almost like draw a line on the graph, and it kind of shows up visually. Like there's a huge spike in the graph when Python 2.7, when support officially ended. And what I suspect happened is you had an ecosystem effect where across the entire ecosystem of packages, package maintainers went in and dropped support for Python 2.7 and then published a new version. So they were likely able to jettison lots of code that they've been holding on to, that they were frustrated with, or might have been a source of a bunch of bugs. And so they were able to release a new version that dropped support for Python 2.7. And then interestingly enough, past that point, the libyear values tend to go up faster than they were before that. So I think that means that the velocity across the open source projects increased after dropping support for Python 2.7. It's almost like across the ecosystem, teams, started putting out more frequent versions of their packages because they were able to drop support for Python 2.7. And so it's neat to kind of see that signal show up across multiple different applications.
So I'm thinking about that. Was that cause or effect? Was it that they dropped 2.7 and now they could go faster? Or was it that they dropped 2.7, but when they dropped that support, they introduced some new bugs that then they immediately had to fix?
Yeah. I think both are plausible. So yeah, cause versus effect there can be difficult to tease out. But I think that kind of gets to a point that I try to keep in mind with a lot of these graphs and with a lot of metrics in general is the value isn't good or bad on its own, right? Like it can be high or low, but low and high might necessarily have, good or bad connotations, right? It's high values warrant more investigation than low values is the way that I look at it, right? And so you want to make sure that you can understand the reason for whatever value you have. Like if the value is low and it's been low for a while, make sure you understand why it's low. It's low because the team's doing a good job keeping update with the packages, or it's low because all of the packages that the team's depending on aren't being updated anymore. So, kind of really looking at that and figuring out and making sure that you kind of understand why the graph you have has the shape that it has. Another thing that shows up on a lot of the average graphs, the total in the average graph, is when teams put in investment to do like a major framework upgrade. So in a lot of Ruby on Rails applications that I've analyzed with Freshly, the total lib year kind of does this stair step up and to the right. And then there will be like this drop where like there'll be like a 50% reduction in the score the next major when the team is upgraded to the next major version of Rails. And then it kind of like continues to go up at the same rate that it was going up before. And then there'll be another investment and it'll drop by like 50% again. But something that I've noticed on these graphs is that it never gets brought back down to really low. Like it's the trend is still up and to the right. The trend is still ever increasing, even though the team has been putting in effort to bring it down at different points in time. And that effort shows up and can be observed on the graphs. And on projects that we analyzed for clients of ours, we're able to then correlate with like, based on our timesheets from that point in time, like what we were working on. I'm like, oh yeah, that is when we were working on a Rails upgrade. Like that big drop in the graph is when we did this work. And so, it's a way that it can show up and kind of be a measure of, how much return did you get on the investment that you put in.
Yeah, I wonder if the constant increasing is just a form of entropy, right? Like time just keeps marching on, and as time goes on, you're adding more features, so you're potentially adding more dependencies, and it's just kind of inevitable that it eventually just keeps going up.
Yeah, and I think like, if you think of freshness as a technical debt measure, right, or a technical debt metric, then I think it's kind of unique amongst those technical debt metrics because with most of them, they only change when the source code changes. So if you think about like different ways to compute complexity, whether it's architectural complexity or individual code method complexity, those values will only change if the source code changes. But with freshness will continue to change even if the source code doesn't change. So the whole attitude of like, let's not touch it, it's not broken, it does start to show up. There is extra risk that you're carrying, even though you're not making changes to the system.
Well, I think that carries with my understanding of technical debt, because if you wrote something 10 years ago and it was written perfect at that time, and you look at it today, most people would consider that technical debt, even though the code hasn't changed since they wrote it then. So that kind of tracks, I think.
Yeah, and some things that we want to get better at, and we want to find some good solutions for are being able to track the versions of the major tooling that's being used. So like the version of the compiler that's being used to build the project or the version of the runtime that's being used. There's not always clear manifests for that information, but where we can get it, we're going to start surfacing that as well. It's not like a traditional dependency that you might think of in terms of like a package that you're relying on, but most compilers or interpreters do ship with a standard library. You can think of like, that standard library being the dependency. And sometimes there are vulnerabilities that do get exposed in those standard libraries.
Well, that's interesting because I do a lot of work in LabVIEW and we talk to a lot of hardware. And so sometimes the hardware drivers, right, there's that LabVIEW package that talks to the hardware driver, but then the hardware driver has its own version. And then sometimes even the hardware itself has its own firmware versions, which would probably be interesting and good to track as well.
Yeah. And I think like, that use case of like communicating with an external device or kind of, communicating with anything external, anything your team doesn't control. I think a practice that I learned from working in aerospace is to build out some tests to kind of qualify those dependencies. So some tests to kind of qualify Like, yes, I can actually talk to the hardware, and yes, I'm confident that I can talk to the hardware, even if it's the kind of test that requires a little bit of manual intervention, such as like, it's a test that runs and then asks you to like look at a display on the device and then type in a value and incorporate that value into the test suite. And so, it could be that like the driver was commanded to display 4 on a display, or to do something that would have had the number 4 show up, somewhere on the device. And then, you then enter that value to kind of close the loop for the test.
Yeah, that's definitely something I do a lot of. Although
Nice.
I have to say a lot of that tends to be manual, but sometimes I get some automated tests around those. Yeah, it's definitely worth doing those types of things. So you do a lot of consulting. Is Freshly something that you use with all your clients and that you recommend that all your clients use? Is there a time when you wouldn't recommend it or when it doesn't add a lot of value?
Not that we've noticed so far. Our big limiter on using it with all of our clients at this point is how many languages that we've built support for with the new architecture. So like, we don't yet have support for JavaScript. That's like high on the list to add in the future. And then, we want to add support for PHP. And then once we have those two, then we'll kind of have all of our current clients covered. We'll have .NET and Java and PHP and JavaScript and Ruby. Ruby's the other one we need to add support for. But having all that built out will then allow us to support our current customers more. But this is kind of largely born out of a repeated problem that we've seen over and over across clients. And it's something that we plan on doing more and more often at Corgibytes, is taking repeated patterns that we've seen and trying to productize solutions to those problems. And Freshly is just really our first attempt at doing so.
So I have a question then. You mentioned that one of the limiting factors is support for different languages. I'm a LabVIEW programmer. Is there a way, is the specification open enough that I could go write my own plugin to talk to LabVIEW, or is that something you guys would have to do on your end?
Yeah, so the CLI is an open source project, and the language agents that we've written are open source. The only kind of closed source component is the website, where you can view the data that's been collected in the graphs and kind of get that analysis and learning from that. But yeah, absolutely, like, you could try and create a language agent for LabVIEW if you wanted. Be really interested to talk to you about that if you're interested in giving it a try. The documentation around that is pretty poor at this point, like as it is with many open source projects. But that is something we do have on our roadmap to definitely improve both the tooling around making it easier for people to create language agents, and then tools for kind of qualifying whether or not the language agent provides the capabilities that's needed by the CLI.
Very nice. So one last question, that is, assuming one of our listeners is using one of the languages already supported, how do they get started?
A couple of different ways. If you go to freshly.app, there are instructions for how to download the Docker container that you can use to run an analysis on your project. The version that we have in that Docker container is a little outdated, so if you happen to run into a bug, then following the instructions for how to build a project from source at our GitHub project for the Freshly CLI would be the next thing to tackle. And those languages that we have language agents built for are Java using Maven. We don't have Gradle support yet. And then .NET. We've got that support for .NET for both CSproj files that have package references in them, and then also the packages.json format that was used for a little while by NuGet.
So all those plugins, I'm going to call them, all those language-specific things are included in the Docker container?
Yeah, the Docker container that you'll get if you do the download, that right now that only has the Java language agent in it. We're working on cleaning up the next version. It'll be 0.6.0. And that Docker container will have both the Java language agent and the .NET language agent installed inside of it. And that's one of the reasons why we're kind of taking the approach of using Docker for the delivery, is that the following the steps to set up an environment correctly for all the different language agents can become a non-trivial task.
Okay, but if I wanted to, I could go to your GitHub and clone it and then build the Docker container from there and include my own LabVIEW.
Yep.
Okay.
Absolutely.
Very cool. Well, thank you, Scott. That was a great and enlightening conversation.
Thanks. I appreciate it. It's been fun.
For Software Engineering Radio, this has been Sam Taggart.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.